So our next fireside chat is titled Cooperation Opportunities and Prospects in the Satellite Communication Application Service Industry. So let's welcome to the stage Bruno Fromont, Chief Technical Officer from Intelsat, calling in from Washington, D.C. We have Lisa Kuo, Vice President of Strategic Sales from Ramon.Space, calling in from LA. And Ellen Chang, Managing Partner at Syndicate 708, calling from San Diego. Thank you all for coming, and thank you everyone for tuning in for our second session. Please unmute your microphones. So we're really excited to have you here and listen to what insights you have. Let's see, do we have everyone ready? Okay. Still pulling in a couple more people. Hey, good to see everybody. Just waiting for Bruno. I think Bruno's calling in from Washington, D.C., so it might be nighttime and late for him. Okay, we'll have someone contact him. He might be having technical difficulties, but let's just get started and we'll have him jump in when he's online. So Lisa, let's start with you. Ramon.Space, it's a semiconductor company designing their own in-house solutions for space applications. You guys are basically building space computers. Can you tell me what kind of difference that's going to make compared to what the traditional satellite companies like Intelsat do?
Well, Intelsat, I mean, we'll wait for Bruno to tell us what Intelsat is doing. However, I have been in the space industry for a long time, and I have seen what the space industry, a more traditional space industry, would do. When they talk about computing capabilities in space, it's very, very antiquated, if you will. Space is a really harsh environment. Space environment, there's a lot of radiations going on, and having a really capable computing system in space has been traditionally very, very hard to do. So all of these capabilities that we enjoy on our little, iPhones and such, we don't have anywhere close to this kind of capability in space, which is a really shocking thing to us at Ramon.Space. Because, we started as a computing company and we thought that, hey, if we are doing all of these awesome computing capabilities on Earth, there's no reason why we can't take it to space. And space is a really a lot harsher environment with no human access to it. We really should be using more and better computing capabilities. So that is why we are going into space. We're doing all of these really awesome supercomputing capabilities. We're bringing to space. Our goal is just to, we are just trying to make the space computing capability as good as Earth. I think, that's like a small step towards building a way better infrastructure such that we can really leverage a lot more capabilities in space.
So what is the benefit to this? I've seen server farms put in the deep ocean, and now we're talking about putting them in the sky. Why is that better than the traditional, hard-coded satellites we have today?
So, I mean, Chris, your panel is a little bit more geared towards communication, but let me give you an example of Earth observation systems. There are a lot of Earth observation satellites out there and taking pictures of our Earth and doing climate studies and whatnot, which is really, really awesome. However, they all have a constraint that is, closely tied to telecommunication, which is you need to send all of those images down to Earth in order to process them, right? So in order to do that, you need a lot of bandwidth. You need access to ground stations all the time such that you can transmit all of these information down to Earth. So, you're going to be, having a lot of congestion on the downlink bandwidth. The availability of the ground station, the availability of bandwidth, And then how do you schedule it such that everybody can get all of the data down? It's going to be congested. And the way that we're currently utilizing our telecommunication systems in space, not very efficient. So beaming down information, not very efficient. And also trying to beam everything down to Earth before you can decide that, oh, that was a good image we took, or no, that was not a good image that we take. Takes a long time to digest that. So a really easy use case for why you need better computing capability in space is such that you can actually digest and analyze the data you take in space before you decide that, okay, I'm going to use the bandwidth and beaming down to Earth. So that is just one very simple example. It's a very similar analogy of, I remember when I was younger, now I'm dating myself, that you could take camera, right? And you have these photos, you take on a camera film, and you don't know if you took a good photo until you get it, developed a week later. And you don't know if it was a good photo or not. It's the same situation that's currently going on in space. You take photos of Earth, you don't know if it's good or not until it gets transmitted down to Earth and you process it. But why do you want to do that? You should process immediately in space. Just like my iPhone, I should be able to take a photo now and decide that, okay, that was a bad photo, I'm going to delete before I save it on my phone. It's a very, very simplistic example, but this is just one of the really powerful use cases why having better computing system in space is going to be beneficial for everybody.
So, Ellen, I get this question a lot, and I'm sure you do. Most VC investment is in software. And just so everyone knows, Ellen ran an accelerator focusing on space. I'm just curious, what do you tell people that are like, why invest in space? You could invest in SaaS, you could invest, enterprise software. What's attractive to you about space?
Sure. So hi, everybody. Really nice to be here. My name's Ellen Chang, again, managing partner of Syndicate 708. I'll just give you a little bit of background. 708 is US 708 is actually the fastest star in the Milky Way galaxy. And that's why we ended up naming it 708. And we're a pre-seed angel stage investor that uses syndication to invest, and we've done several deals. I think the largest is probably Orbital Sidekick, which is now just raised a Series A. Their lead investor is actually the Singaporean sovereign wealth fund, Temasek, but they also have U.S. Air Force dollars in them to the tune of 16 million. So why invest in space? There's a couple of things. If you look at where the market is going, there's projected by some of the key banks, Goldman Sachs, Morgan Stanley, that this industry is going to grow to over 3 trillion over the next 10 years. So there's so much opportunity. Not everything is about the constellation, however, but a lot of the components, the materials, the ground segment, also a lot of software. Space has a lot of software. And so we see so much opportunity in all of those domains in terms of investment. What do I tell investors? It's actually getting a lot easier to talk to investors about space. When I started investing in space and when Lightspeed Innovation started, it was back in 2015, so it's 6 years ago. And I came out of a company, Northrop Grumman, that had an aerospace sector. I was both on the systems engineering side and later went onto the business side or program side. So I could speak both languages, if you will, the technical as well as the business. And it took a long time educating investors what space was about and why the multiples, why it's worth the investment. The multiples still might not be there. So deep tech, or what Syndicate 708 focuses on, is essentially certain types of domains that probably have engineering or technical risk. But we believe that the potential is so strong. And so there are a lot of investors that increasingly are understanding what the risk is. And we work very hard to help them understand how to balance out the risk and reward ratio. I think, software certainly is really popular. but it's the investor market understands software, whereas space that we're still trying to understand, or we're still building that understanding, at least in the US investor base, in order for more investment to come in. Most recently, over the last year or so, there have been a lot of public offerings that have started to catalyze more capital coming into the sector. But it's still hard. Space is hard, technically. Space investment is hard as well.
So the title of this conference was NewSpace Forum, and it's really great that both of you came from, I don't want to call it old space, we'll call it traditional space. Mm-hmm. What just to explain to the audience, what is that differentiation, and also what are the traditional space companies doing to kind of move into the new space, because clearly they're still around and they are working with a lot of the new space companies. So yeah, both of you, please.
Lisa, why don't you go first?
So, you know, I have been in the traditional space for a very long time. I do claim myself Ramon.Space as a new space. However, I have also seen new space company becoming traditional space-like. Like, for instance, a really good example is SpaceX. You know, they started as a new space company, but if you look at how SpaceX is operating today, it's looking more and more like an old space company, right? So I think, you know, I really don't think there's a clear differentiation between traditional space and new space. In the past, it used to be how they operate, how they design their missions, how they structure their business case. You know, the new space company has this kind of a model that it's like the Silicon Valley model, which is you build it, they will come. And that was their business model. They have a mission, they want to achieve something, they go and build it, and then the customers and investors will come. However, the traditional space operates in a very different way. There is first a requirement. There's like somebody has a mission, you know, whether it's a government, NASA, or some kind of big companies like such as Intelsat, who has a mission requirement. They will have a mission requirement. They design to that mission. So it's a kind of a different mindset of how they go about market. So that's how I see difference between a traditional space and new space. However, I have seen a lot of traditional space have started adopting to this new space model, which is you build it, they will come. You know, you believe a mission, you believe a certain solution that is going to solve a lot of people's problems. They build it, and they go pursue customers after they come up with the concept. So we're seeing a lot of mix between new space and old space. And I am really hoping that eventually there will be no quote unquote new space versus old space or traditional space. It's just everybody going after space as a commodity market.
So Bruno's here. Apologies, we started I think 5 minutes earlier than I had told Bruno, so that's my mistake. But welcome Bruno to the stage from Intelsat. So we're just to fill you in, we're talking about kind of the differences between traditional space and new space. Intelsat, of course, is a very traditional company, but really going through a lot of changes right now. Like I saw that Intelsat ordered 2 software-defined satellites from Airbus. Can you talk about that and kind of what the direction is? And then we'll continue on about this new space, old space kind of discussion.
Isn't it fitting that I'm here on this panel on new space, and I'm representing perhaps the the oldest space company in the universe? So that's interesting. Yeah, we're excited about our transformation, and just Chris, to come back on this announcement. I think this is significant. It's not a milestone, but it's been an evolution. But the landscape of regarding space technology is changing rapidly. Software-defined satellite for us means speed, flexibility, and reduced cost. At the end of the day, and you may have read this article by Mark Andreessen in the Wall Street Journal back maybe 10 years ago about why software is eating the world. And traditionally, space is a very hostile environment. It's really hard. You need to make things work. You cannot touch it after you launch something. for a while, and so we rely a lot on hardware, and we are in the process of transforming our industry to move towards a more software-based technology, because software allows you to be fast, to deploy your services faster. You look at the 10 largest cap in the world, they're all software company. They are not hardware company anymore. And more practically for our customers, it means that we can now intervene and change the connectivity for our customers in real time. We can basically project and define communication, where we want it, when we want it, and that's a big change. We started to push the industry, I would say, 10 years ago on this, to build faster and more complex processors, to change all the switches that were the essence of satellite communication, and now this is now run by a computer, and there will be more in the future.
And so just to come back to my question right before you jumped in, traditional space and new space, you are the oldest company in the universe in space. What is that? How are you guys going to transform into kind of a more new space style company? And also, Ellen, feel free to jump in for your perspective.
Yes, thanks for your question. First of all, I think we have a great business. We start from there, and we make, we have a revenue of $2 billion. We have great customers. We serve 2 billion customers for video content around the globe. We serve 8 out of 10 of the largest mobile operators in the world. In all verticals, we have a great position. But
you just bought GoGo too, I read.
Yeah, we acquired GoGo because, well, that's a different story. I'll come back to it.
Okay.
Because we think there are great market opportunities in mobility. So it was, part of the logic, of course. The other is, of course, try to repair a bit, the value chain, which we thought was a bit broken, and getting closer to customers. We realized that just selling wholesale capacity and not understanding the intricacies of, let's say, serving what works, doesn't work on an airplane. There is a bridge too far, and we need to understand deeper if we want to build the right solution for this type of applications and customers. So I don't know that we're going to repeat that in many verticals, but I think it's something that can make sense in some segments. But the transformation for us is first and foremost, obviously clearing our balance sheet. We saw an opportunity after we did participate in the 5G repurposing of the spectrum in the US and with that capital, we saw a chance to really fix our balance sheet. As I said, we have a great business. It was not just a matter of changing that, and now we are in a position where we can apply our ideas to new investments, and take advantage of the innovation that is now available in new space, and try to again embark on a new journey. So it's really new Intelsat now.
Yeah, let me jump in there. So I thought Lisa did a great job talking about companies that might be a little bit more focused around requirements are provided to them. Maybe it's like government backed or government funding, to then trying to intuit what the market needs. There's a couple of other frameworks I would like to introduce. Sometimes new space is really kind of the new companies, new technologies, often venture backed, or maybe at least private capital backed companies that have started to pioneer some new ideas. Like low Earth orbit wasn't anything that anybody wanted to talk about, even 10 years ago. Well, we tried it back in 1998, 99. Teledesic came, basically the cellular industry, terrestrial industry kind of derailed that whole effort. And then everyone got scared and didn't want to go into it again. But the change is that the computing and all the materials and technology is so much less expensive. And so we're doing it again. Another way to think about it is also government commercial. I feel like Intelsat is more maybe commercial comms. Maybe they also have to think about the market, that no one's giving them requirements. Whereas there's a whole sector that, depending on the culture of the company, they might not necessarily make a move without the government telling them exactly what they want to build. So there's several frameworks. It's big, small, new, maybe new technology oriented, venture backed. But that's kind of those are the frameworks I would use.
So you brought up earlier while we were talking about software. You know, everybody's looking at rockets, satellites, communication. It's all great stuff, but what are kind of the space-enabled softwares that companies like Ramon.Space are going to be able to enable?
I can.
Yeah, go ahead, Ellen.
I'll jump in there, Lisa, and then you jump in. So I remember earlier I mentioned a company called Orbital Sidekick. They actually are launching hyperspectral satellites, but their real main focus, they call themselves a data company. And so they're building and collecting data on the in the hyperspectral type, and then they're building basically algorithms, machine learning, to tease out insights from all of the data that they're collecting. So generally, they're kind of a software hardware company. I guess in the Valley, they call them software and enabled hardware, which is kind of cognitive dissonance for me, but essentially I offer that up. Go ahead, Lisa.
Yeah, so your question about, you know, how Ramon.Space sees, you know, how the software-based future looks like. So, you know, the honest answer is I don't know. And I'm really proud to say, I really don't know what is the future of all of these software-based. It's going to be so much more flexible, so much more things that we can do with software, right? And what we want to do as Ramon.Space is we want to make sure the infrastructure is there, such that we can enable more and more different software, different applications, things that I can't even imagine myself. But we want to have the infrastructure that's there to enable all of these crazy ideas that, you know, might come in the future, that one day we'll be all using it one day. So that's kind of our vision. And that also explains how we stand about software. Sure, we write software, certain applications as well, but we really, our really core mission is to enable more software, more applications. You know, we shouldn't be the one who's defining what kind of application and software that should be on all of these computing infrastructure.
Okay. So I guess a question that probably a lot of these audience members want to know, being that there's a lot of manufacturers here, is where are the opportunities with Ramon.Space, with Intelsat, and just space in general? First, considering the low-hanging fruit, terrestrial type of technology, and then maybe further down the line, more space applications.
Oh, want to go?
Yeah, I'll actually jump in there. So I remember doing a study along with Infinio Capital around Taiwan and Taiwan's comparative advantages. And we know that the computing industry is so large. So I was ideating around what could they do. I just feel there's so much opportunity as the space segment starts to shift and change and upgrade. Certainly the ground segment has to follow along. And so there's probably material, you know, if you're a material science person, you're probably in your heaven, because there's a whole bunch of materials science that can actually add to the flexibility of antennas, et cetera. I would say just the fact that virtualization is happening, that we're able to network together computers that seem to be one and use software to do a lot of data throughput management. I think there's a lot of opportunity there. That might be software, but certainly there's definitely the computing hardware platform. And even as the cloud comes together, there's all of those opportunities. From a Taiwan kind of industry perspective, going back to the materials and also the antenna and even just the ground components that need to be built in order to support all the space capability that's there. Those are all opportunities. And given that Taiwan is one of the most competitive manufacturing, you know, kind of essentially entities, I think there's, you know, we just need to position correctly.
Just to give you, you know, some figures, you know, we use, you know, we spend an inordinate amount of capital to maintain our fleet, or, you know, a fleet of geo satellites, and we are looking at, you know, different other opportunities in other orbits as well. But we usually spent, you know, 80% of our capital towards the space segment. We are now reaching, and then 20% on the ground. We doubled that in the last few years. It's now 40% easy on the ground segment, Why? Because of the scale factor, because we want to touch more people. I mean, think about it. One of the big transformation for new space is also the advent of new standards. I mean, I was boasting, the number of terminals or customers we have, but we are dwarfed by traditionally by the IMT and the telcos who serve lots and lots of end users. This is a chance with 5G and then in the future with 6G to see really a real convergence of the chipsets to handle both space communication and ground and terrestrial communications, mobile communications. It's a big shift. It's going to enable a scale. And when you think scale, you think manufacturing capabilities to reach low cost, for the users, for the terminals. So I think, participating in the standards body, I think is very important, because you can be at the forefront instead of just, taking orders. More and more we'll need to anticipate, create ventures to understand what can be done before you jump into a manufacturing process. I think it's going to be more and more important, so that the future can be baked a little bit before we go to full execution and manufacturing. So lots of interesting things. And of course, I cannot agree more with Ellen about the software opportunities and, space component as well. I mean, all what is antenna related silicon for shaping and creating all beams on the spacecraft, on the ground. These are very important, technologies. Lasers, think about future frequencies. Lasers, I think, are going to play a big role in new space.
I'm going to follow the same thread from Ellen and Bruno, especially on the last part that Bruno was talking about, all of these applications in space. So, I'm a Taiwanese. I know what Taiwan is really good at. And when you talk to other people about Taiwan, first thing that comes to other people's mind is, oh, they make really awesome semiconductors, computers, everything about computing. Taiwan is top notch. So of course, I asked myself, how come in my whole entire tenure in the space industry, there has not been a lot of Taiwanese company that reached out to any of these companies or any of these other collaborators that I have worked with to see if there's any collaboration opportunity. There's a lot of opportunities, for Taiwan. Taiwan has a lot of really good, product that is world famous, and they really should leverage that into, okay, if they really want to go into the space market, they should leverage all of those. So I'm just really surprised that I haven't seen, a lot of the requests from Taiwanese companies for collaborations or cooperations, but lots of opportunities, guys.
I think are some of those challenges. Why aren't they approaching these companies? Because as you're all talking about, the capabilities, at least some of them are there.
Yeah, so I'll go first. I have seen a few Taiwanese companies in the past that tried to do space, but I think they are, number one, Taiwan, I understand this very well because, Ramon.Space is an Israeli company, and Israeli company have a very similar culture that they focus on technology so much, right? It's about, okay, we want to deliver the best technology. However, space is not just about technology, unlike, semiconductors and computers. Space, there's a lot of, national pride that's involved in space. There's a lot of, it's a really niche industry. So you need to do a lot of marketing. You need to, do collaborations and cooperations with partnerships. Those are really, really important in the space industry. And I think Taiwanese companies who want to come into space can do a lot more in marketing and cooperations and partnerships. And I think this is going to really play out, and it will come to fruition in the long run if they invest more time in those areas.
And Ellen and Bruno go ahead, Bruno.
Yeah, no, I just to complement, first of all, I think I've been to Taiwan only once, myself, but I'm looking forward to resume, the discussions here if possible, because I think really, you said it, Lisa. I mean, on one hand, space and new space, is kind of a niche from a value perspective right now, but I mean, from a growth perspective, I mean, the opportunities are, ginormous, and so we need to think about that, and at the same time, space, by definition, touches the entire planet. So it requires a lot of cooperation. Whether you want to launch something, you cannot do that on your own, perhaps with some remote sensing systems. But when you talk telecommunication, you are cross-border by definition. You serve your interests, but also you want to communicate outside of your country, and you want to establish standards. So, and so to be successful, collaboration for space. You see what's happening, with the International Space Station. There's not a national space station. It doesn't exist. You need to to go out of your comfort zone to be able to establish the relationship, and also the innovation and the pace that is required right now. As I mentioned that before, but you cannot afford not to anticipate, and so therefore having a joint venture or a framework that allows you to anticipate needs before you just take an order is extremely important, because the possibilities are so vast. You cannot just pick and choose and just work on technology in isolation. You need some level of blessing or vindication of the path with others, consortiums, and collaboration of some sort.
So you're talking about joint research, maybe joint ventures. What are kind of some of the technologies you all see that are on the horizon that can leverage Taiwan's capabilities?
Computers, of course, computers. That's what we do. So, and that's what Taiwan's famous for, computers. It's a very natural progression. We need more computing capability in space for a lot of different applications. Taiwan's very, very good at making computing systems. So, of course, that is a very natural progression. That's a really, easy path for Taiwanese companies to go into space. But that's me. Ellen?
I think there's even just applications wise, what's needed over in Asia in terms of any types of communications or Earth observation types of capabilities. But when I go down to the technologies, I'm actually going to answer your last question. What can be done to, I guess, stimulate the industry a little bit more? And I'll go back to the government side. Chris, you had asked about, what could Taiwan government do? Here in the U.S. and many other countries, there's grants and there's funds that actually help seed some of the technologists or inventors that push them forward. And I think maybe there's a little bit of imposter syndrome. They're computers, they don't understand necessarily how it applies. Certainly the space environment is, you need rad-hardened types of capabilities, maybe not to the extent of something in GEO, but maybe something in LEO. You still need something, right? And so I think the government can actually lean a little bit forward and start to stimulate the ecosystem. There's certainly several models around the world that could be looked at. The UK has a very interesting one that they're trying to add money for. The Israelis always de-risk some of the private investment. And then, the US government has government funding. There's great opportunity there. There's also problems. From going back to the joint research, that's exactly, reaching out to understand if there's an alignment to conduct joint research. I think the biotech community and the life sciences community does this very well. Is that a model that the Taiwanese community can actually leverage? Possibly. There's actually contractual types of models that could be looked at, and that's actually innovative. That probably out innovates the U.S. because they're not looking at it from that perspective necessarily. I'll pause there, and maybe Bruno has some comments.
No, I think you nailed it. I think from a framework perspective, and maybe I can add, as a CTO, a few more, areas of, where technology can be deployed. I mentioned the terminal, but specifically all things related to phased array, or where a lot of research needs to be done because we manipulate frequencies and bands that are not used terrestrially or not that way. And I think here there's a huge prize for whoever is able to develop terminals that are cheap and have a nice form factor. It's amazing what could happen there. We mentioned the computer. I think 3D printing and the type of component that can be flown into space are have some unique properties. And I think, who masters, 3D printing, that you can print rockets now, which is, quite amazing. So I believe there are a lot of things we can do to automate and use new components, new material for space using 3D printing, and that can unlock some cool, performance and technology down the road. So that's very important, and everything that's remote sensing. I believe, we talk about telecommunication a lot. There are opportunities more and more to blend and fuse data from sensors. This is something that NewSpace would be very good at. Small, sensors floating in LEO, but also bigger communication satellite, all this network together, and the information that is sent from a market perspective to users is usually a blend who can aggregate big data, from sensors with a communication network, can create a very interesting platform. And so, these are the other areas that I see that could be very, very important for the planet, actually.
Okay, I have a question from the audience. You just brought up LEO. Someone is saying, so the average LEO satellite is 3 to 5 years. For such a short product life cycle, what are the cost pressures with space assets to make it financially viable? Any takers?
I can start, and maybe I will be controversial initially, and and I'm going to use my old space hat. There is a reason for that. We've been, quite prudent beside our financial situation until recently. Is because GEO is a very proven model. It's a very interesting and unique vantage point on the planet, so you can really tailor your communications. But of course, you're very far from the end users. And LEO, I would say, I see great potential for, again, remote sensing. You see of course the use case of GPS signals, and this is very proven. But if you want to do really broadband, I would argue that, of course, it's very doable, but it's very hard actually to make a sustainable business case. Of course, if you have a lot of money, if you can afford to lose a lot of it, seems like Elon is doing that right now. You can try, but this is still a business that's very hard to establish. And the question raised a very important point. You cover the globe. You need to deploy hundreds of thousands of satellites. Cost a lot of money upfront, and you need to fill that constellation from every part of the globe, where you have barriers to entry, and it's very hard to do that in parallel. I would argue that there are other orbits that could be very interesting too, that don't need to be so close to the Earth, and from a communication perspective could be actually more efficient. So more like MEO, or in this place. I mean, it can be also an interesting vantage point.
So we touched on GoGo earlier. And you said you're going to kind of explain that acquisition. So do you see this type of internet access in the air or other areas as like your future growth, kind of your growth engine?
Yeah, I mean, for the industry at large, I think the mobility market grows at about, despite if you abstract the COVID situation in the past couple of years, but which slowed down travel, of course. But whether you think about maritime, land mobility, and of course the commercial or government aviation and everything that flies, it's a growth market for the industry, because by definition, no terrestrial network can access these users. And of course, it's about broadband connectivity towards ships, towards government platforms, towards planes, but I think it can, and this is growing like 10-15% per year, which is remarkable. But at the same time, I think this can mean far more. I think it leads to Internet of Things for all these moving devices and terminals. That when you fly a plane right now, you fly pretty much like if you were like in World War II. I mean, there's no you rely on beacon, on black boxes. It's just so much data can be dumped from a plane, to manage the flight path, to get a better experience for the pilots, to save fuel and all that. I mean, there's a huge market for connecting everything that moves.
So, Ellen, I was asking her about, convincing investors to put money into space. How do you convince a lot of the people in the audience, the manufacturers, to actually work on this? Where do they make money right now?
What's the ground segment worth, Bruno? What's the total available market there? Billions.
Yeah, billions and billions. Yeah.
Are there any other technologies? I mean, yes, Taiwan can work on the ground stations, the antennas that are so important, phase array. Are there any other technologies that you feel like they could go into and play a big role?
I think I'll just jump in there. So even as we move into space and we want to do, let's call it, maybe you want to repair satellites in space. There's going to you need sensors that actually can sense and interpret, right? So there's going to be sensing. There's also going to be robotics. So any sort of robotics types of technology, from even autonomy that enables some of the a robot to manage itself. I think those are all opportunities that will help push us forward, because the technology is starting to be there. We already know that some of the satellites can be refueled, right? We're playing around with those concepts. I'll cede to the other panelists.
Just believe me, I had one. I've been in this industry for a long time, since I was young, and then because I was passionate about it. But recently, I had one of the most thrilling moment of my life, actually, when we actually docked this robot, mission extension vehicle, to one of our satellites after this satellite had been in space for 15 years, and we spent 2 days coming close, like it was like with cameras, like in a movie. Typically we launch satellites, we never see them again, right? And then you can see that satellite, see what happened, all the meteorites that hit the different panels. You can come close, 50 centimeter, and then closer and closer until we dock in real time to this satellite, then bring it to a new life. And it was a very, very emotional moment for many people. It's what robotics can do, in space. And I think there is a whole, new industry that could actually be, to Ellen's point, could be created around that, servicing, augmenting, replacing the cards on a satellite. I think that's a possibility. I've looked at many projects like this. It's not a reality yet, but if you want to look into the future, robotics and doing construction in space, repairs, that's a big deal.
Yeah, I wonder how much they spent on the Hubble to repair that.
Yes.
Go ahead, Ellen.
Yeah, to that point, right? There's and it needs to happen. And then what Bruno mentioned, there's already startups that are trying to build towards that. We have this company here in the States called Orbit Fab. They want to be gas stations in space. Then there's other ones that are trying to help the satellites maneuver to save gas and also probably avoid space junk. So as the space gets a little bit more crowded up there, there's certain other types of risks that then we need technologies to help us manage.
And remember, space is very cool, like literally it's very cold. So it's perfect for Bitcoin manufacturing. If you have a right computer, there's an online industry that can be created over there for that.
Bitcoin farming using solar. Lisa, we need you right now.
Okay, yeah, I'm on it. Actually, I'm going to echo back to one of the earlier questions that you asked, Chris. Sorry about going back, but you asked about what's the difference between new space and traditional space, right? And I have to say that like company like Intelsat, traditional space all in all, but how are they adapting to these kind of new space environment by adapting to these new technologies, right? They're the first one. I think they're the first one who say, oh yeah, sure, we'll dock a robotic arm and do all these space servicing to us. This is a prime example of how all of these traditional companies are trying to merge with the new space and make them look more like a new space company. And then on top of that, as you can tell from all of these, you need international collaboration because you have to work with a lot of different companies, a lot of different countries in order to do any of these things, right? There's a lot of opportunities in space. You always need to be collaborative with and do partnership with a lot of different international companies. The opportunities up there, like I said, there's so many. I can't even count how many opportunities there, but you do have to go out there and form some kind of partnership, and that's definitely the key to being in the space industry.
I just wanted to add one thing which is we need to be all, and I think you should be, fascinated and excited by the opportunities. But that notion of collaboration is important for two reasons, of course, because of the scale of the investment that are required. Again, these are, global investments. Usually it's hard to start from just one place and make it happen, even though it's possible. But also, I just want to remind people, but of course it's rocket science. So failure is an option. and when it fails big. You've seen this explosion, these things. Without comparing notes, it's like, the airline industry, you need to learn from your mistake. And if you start from scratch purely alone, you are going to make mistakes, and these mistakes are very costly. So managing risk is a way of life for space industry. And whatever you do, whether it's a computer, it's something's going to fail. You need to think differently about the environment.
Oh no, do we lose Chris? Oh, we'll talk among ourselves.
Maybe I should ask, what questions should we be answering?
Mm-hmm.
Provide the Taiwan kind of as
I know.
next generation.
I think there's a lot of opportunity for Taiwan, and like I said earlier, in my whole entire career in the space industry, I have not seen a lot of Taiwanese companies that reach out to whether my company or some other companies. It's not compared to some other countries, right, who understands the very nature of a space industry, that you have to work with a lot of different nations. If you look at, of course, OneWeb is a really extreme example, but OneWeb at this moment is owned by UK and India, right? Go figure. So it's always going to be like this, a lot of collaboration across different nations. We, like Ramon.Space, will, shameless plug, but we will love to have collaboration with, some Taiwanese companies. So anybody who's interested in collaborating with us, hit me up. Too bad my, the little, I don't have my name and the QR code here, but.
We can probably put it in chat, and then let me ask this question. So one of the members asked, in satellite assembly, what sort of material is needed most? If we are able to provide aluminum, titanium, nickel-based parts, will that have an opportunity for a Taiwan supplier to provide the assembly or the parts? So anybody want to answer that?
Yeah, I think the answer is always yes. You have to find the right partner. Doing these parts, and it's not like the computer industry that you can generate piece parts and then send it to somebody, and they'll, space industry, usually they would like to do more vertical integration, like the whole entire spacecraft. They would like to see the manufacturing the whole entire spacecraft in-house. So again, I can't emphasize enough how important it is to have collaborations.
Mm-hmm. And I think on materials, yes, agree. All of the above, but I think new type of materials will be, of course, needed as well. In the sense that I was mentioning 3D printing, what you need to send in space, the lighter it is, the better. It's a complex, equilibrium between, at the same time protecting against radiation, so it's kind of a hostile environment, but at the same time it needs to be light, because everything you send, you pay for a launch, and you pay by the ton, right? It's very heavy. So I know companies that have started to look at, the way to put plastic in space, make plastic, coat plastic with, materials, that to make the wave travel better. I mean, there are a lot of innovation that can happen, to make this, the spacecraft rely on new type of material.
By the way, I'm back. Sorry about that. The app crashed and I couldn't get back on, but I'm back now. Hope you're able to continue the conversation.
We did.
No problem.
Self-moderated.
Great. Okay, let me go back to some questions. Let's see. Aside from these traditional hardwares, older industries like precision manufacturing, casting, forging, those types of industries, materials, where are the opportunities for Taiwan in that space?
I think we touched base on this a little bit when you were gone, Chris, but we answered part of it, but I think there's definitely opportunities. I can't, we're not in the position to tell you exactly where to go to search for opportunities, but there's definitely opportunities, via collaboration and cooperation, some kind of partnership. Space, because of its mission critical, most of the manufacturers like to do things a little bit closer in-house. So, having some kind of partnership such that you are part of their in-house provider and vendor, I think it's really helpful.
Okay, I have another question related to power. Taiwan is very big with companies like Delta, Lite-On in power supplies. Lisa, for onboard intelligent computing in space, is there enough power with current technology? Is this a bottleneck?
That's a really interesting question. So yes, in space, because you're limited by how much real estate you have on the spacecraft, which real estate means, size, weight, and power. So you're limited on all three fronts. So yes, having a more power efficient system on board is always more preferable. So I wouldn't say power is a bottleneck, but definitely, having a more power efficient system is going to be more preferable because again, the most expensive, and Bruno can attest to this, actually the most expensive part in the past used to be launching to space, used to be the most expensive part. The satellite itself, it stays there for 15 years on a geo satellite, but launch lasts for, I don't know, maybe a day or two, but it costs as much as a satellite, right? So, on the most expensive part of launch is size, weight, and power. So, if you can reduce your size and weight, it always is going to be more cost effective. So I wouldn't say it's a bottleneck, but it's definitely a limiting factor.
So your space computer is actually powered by solar, or?
Yes.
Okay. Wow, that's quite efficient.
Yeah. And I think again, the computers that are manufactured or built by Ramon.Space or other computers and hardware. I mean, these are things that are very efficient. So it's that balance, being again, the more computer and dedicated hardware you have, the more exposed you are to radiation. But if you can survive and put the right redundancy, think about red technology and make sure you're not depending on a single failure. Then everything is powered by solar panel. It's a very green technology.
So for those computers, what kind of components are we talking about? I know there's the processor. I've read that power PCs are still being used from 20 plus years ago. What's kind of the computing power you're at? What kind of memory? Things like that.
Is that a question to me?
Yes, Lisa, since you're the space computer person.
I can't go into the details because I'm not the technical expert. I don't want to butcher our capability, but you're absolutely right. Power PC, I know some of the traditional, satellites do use Power PC, which we laugh, but it is a very tried and true and proven technology. And we have, again, the space radiation environment is really, really harsh. So in order to perfect a computing that can still work well in that kind of radiation environment, it takes, most of the time, it takes a lot of investment and a lot of R&D into it to make your computer capable while still being able to withstand that kind of environment. And then exactly like what Bruno was talking about earlier, failure is not an option. So you have to have, built-in redundancy, or, what if it fails? You're not going to shut down the satellite because it fails. So you have to take a lot of things into consideration, because space is really, really far away, really harsh environment, and you can't just send your IT guy to, hey, just go fix it. You can't do that.
Yeah, and it's just to add, I mean, there is, I mean, I wish, frankly, as a user of computing technology, and that we would keep pace with the innovation that is happening on terrestrial. It's not exactly possible because of, again, all the hardening requirements. However, I think, we are catching up quite a bit. And I would say it's hard to quantify, in terms of speeds. And think about it this way: there are lots of also dedicated chips that are built for space, ASICs, FPGA technology, because the way we reason, the way it works right now, it's a lot of analog digital conversion. You sample the spectrum that comes to your spacecraft. You sample all these bits, and then you process them, you route them, and we process a lot of information. Think about gigahertz, dozens and 20 and 30 and 40 gigahertz worth of bandwidth that needs to be processed real time, rerouted to different channels. You need to create beams, in real time. So it's a lot of information that needs to be processed. So it's a lot of parallel processing.
Okay, I'm being told we have time for maybe one more question. Someone is asking from all of you, what do all of you feel about the trend in SPACs for funding space companies? Do you feel like this is a good trend, or is this setting up the investment community for a big disappointment?
Question. I think it's both. It's a great trend, or it was folks who got out. And so it actually catalyzed a lot of activity. But now these companies have to perform. And at least a couple of my friends who have pipes, essentially they raised money and are looking for target companies to take public, or basically, bring them along, I guess, is they're having a hard time finding companies that actually will meet the SEC's requirements right now. So the US actually went through a lot of activity where a lot of SPACs went public, not just in space, right? Like everything was going public, like pharmaceutical companies and life science, everything was going public via SPAC. And now the SEC is kind of basically tamped down and added a lot of restrictions. So I think it's both. And hopefully the space companies do perform, because if they don't, then it's going to really dampen the early stage investment.
There's a lot of money that seek, investments and places to be and provide returns. And I think first of all, it's a good thing from a visibility perspective. It did attract talent, capital, new sources of funding, enable new projects that otherwise we wouldn't have found any takers. I also know for a fact, I review on my desk a lot of potential investments and things. I mean, we need to be careful about the hype. It's very, the US is known to be sometimes very exuberant, and on the verge of creating a bubble for things that look good but will never make money. So we need to be very careful. We talked about not the deception, but the disappointment in the 20 years ago with in early constellation. So it seems like if you say I'm doing a LEO constellation these days, you can get funding, but it's not that easy. And as I said, technically it's always easy to do something, even though it's a big project, but to find customers and please the customers, it's a different business. And you need both to make a living.
Space is still somewhat of a niche industry, so I think investment, you have to take that into consideration. It's a very capital, well, it used to be, it still is capital expensive, and also you need you have to look at a little bit longer term. There are so many space companies that went, bust and then come back and they're doing well, or vice versa, right? So you just have to keep that in mind for all of this. But, as a startup, of course, I welcome all of these SPACs.
Okay, to sum it up, I think a lot of the listeners are just interested to know from a government standpoint and a corporate standpoint in Taiwan, what more can they do to just be a good partner and an attractive partner to startups and established companies in the space?
Jump in there. So the government, especially with the space agency, I think two things. Maybe there is a program to help de-risk some of the newer technologies besides internally funding, but funding companies to pioneer on those technologies. But not just that, there's so much know-how over that has been built within Taiwan over the past, I guess, 10, 15 years. How can you actually provide that know-how to the companies, to the industry? Those are all very valuable to startups or to any sort of company that's looking to take the risk to migrate into a new domain.
Mm-hmm. Well, from my standpoint, I mean, I would look at it, as an outsider, and the first thing that comes to mind for me is frankly communications. By that I mean making sure we have the government can create a mapping between capabilities and opportunities, and this is valid internally. I mean, within the country, but for a company like Intelsat, the reason I'm on this panel is also because we are looking to invest, looking for new partners, ways to find new ideas, technology, and it's hard when you don't know. You would like to understand better the landscape, understand whether you can find and match your needs with capabilities, capital, and get going. And so the first thing that precede any business, any opportunity is like intelligence about about the information, about the industry, the name, the people, the companies. It's hard to make a deal if you don't know the people. So creating that bridge is a first step. I mean, at least for me, to understand, how we can take advantage of collaboration and opportunities.
I second Bruno. I think I emphasized this multiple times in this panel. Partnership. Go out and find partners and joint ventures and work with somebody. Space industry is a niche industry. You need to make connections and you need to form alliances and find the right partner who can bring your technology into the rest of the world.
Okay, great. Well, thank you, Bruno, Lisa, and Ellen for sharing all your thoughts and insights. I think they want to do a group photo. Yes, I'm told they want to do a group photo, but I just want to thank everybody. This pretty much concludes our program. I want to thank BOAST, IDB, eTree, and Infinio Capital again for supporting the NewSpace Technology Forum. Thank you all the speakers in this session and the previous session. And we hope that all of you, audience and participants, can take part in this new space revolution. If you have any questions, feel free to reach out to any of the speakers. And thank you again.